Hello, my name is Olukemi Akintewe from the USF Department of Medical Engineering. I will be talking to you about remote lab teaching for BME 4056C, which is a biomedical engineering lab which focuses on bioinstrumentations and engineering physiology. First, I'll talk about the experiment. How did we convert from face-to-face to remote labs? And we incorporated the use of both videos available online through YouTube's. We looked at data from previous data set, and we looked at looking at existing softwares online. And then for Canvas, we used Canvas for assessment and weekly announcements. We used Blackboard Collaborate Ultra to meet up with students for lab hours, office hours, and final project presentation. For the project support itself, we've used a licensed software, iWorks, and free software, LT Spice and Tinkercad. So first, for the lab experiments, the first experiment was for students to take a schematic diagram and then obtain all the components necessary for building the circuit diagram. And they were supposed to go to the GFX lab and solder each one of this component on a circuit board. So the final product was supposed to be a printed circuit board. So with the conversion of trying to still allow students to come up with have the same learning outcome, what we decided to do is to provide students access to the same type of learning objective, but we asked that the students create an account on an Autodesk, which is an AutoCAD, and have the students create an account on Autodesk Eagle so that they will be able to actually complete that particular lab experiment of building the device. And the protocols were generated such that the students could follow the step-by-step protocols and for them to be able to achieve a printed circuit board. So next, they were supposedly supposed to use a circuit board, which is a neural amplifier, for them to use that to collect action potentials from cockroaches. This was a nerve conduction study. So to mimic them actually collecting this data, setting up the experiment itself in lab, YouTube videos were sent to the students. And the YouTube videos were actually from the manufacturer of the neural amplifier, which is the Backyard Brain Spiker Box. So they had tutorial videos online, and those tutorial videos, students can watch them and they can actually build the devices by following the tutorial videos. So students are able to watch the tutorial videos, and a protocol was given to students such as if they were to have the particular materials at home, they'll be able to follow and then be able to measure the nerve conduction of a cockroach. So after that, students were then given actual data, and this was data set from previous cohort, and the students were expected to use that data to complete the post-lab for that particular experiment. So next was the Canvas, how we used Canvas. So weekly quizzes already given on on Canvas, but the exams were face-to-face exam. So we went to the online exam. And for the online exam, in order to prevent or try to reduce cheating, we incorporated the use of downloading the lockdown browser software. So what I found out with that, I didn't find that to be quite effective in preventing cheating, because students could have multiple devices open, and this only locks down that particular browser on a particular device. So I didn't find it to be effective. Another way that we used Canvas was for announcements. So weekly announcements were sent out to students as what to expect and what students needed to go to find particular information. And this is an example of how the weekly announcements were generated and sent out. For the lab interactions and student interactions, all lab hours were maintained by creating sessions on Blackboard Collaborate Ultra. So students can hop into the session, and the TAs were already waiting for the students. So students can come in and drop out at any time. So the expectation was that students will be working on the lab modules during the lab hours. And if they had questions, just like how they would in the actual face-to-face, the TAs and myself will be available on the Blackboard Ultra. And students did come in. Oftentimes would typically be at the beginning to get clarifications for what is expected, and towards the end, we did see a lot of students would come into Blackboard Collaborate Ultra for questions. And then with Blackboard Ultra, you can create breakout rooms. So one particular TA can take a group of students and then have a private session with those students. Another thing I use Collaborate Ultra for is for office hours. So students can always come in during those office hours without sending an email or trying to get a one-on-one appointment. But I was always going to be available. I was always available during those office hours, so students can come in at any time to ask questions. And the last thing that we did use Collaborate Ultra, Blackboard Collaborate Ultra for, was the final project. So with the final project, it was supposed to be a poster presentation done in a way where students will have experience of what happened at conferences. And faculty members in the department were already being invited to judge those posters. So to be able to still allow the students to gain those feedback, those PowerPoint presentations were now electronic virtual poster presentations, where students were assigned a particular poster presentation time slots, and the group members would be on the Blackboard Collaborate Ultra at their specific times, and faculty members were invited using the guest access. So faculty members were invited and students were able to present, and then we did judge the students' work and wait till the next set of the next group. So this was quite effective in providing feedback to students, a live feedback to students. So for the project itself, so the goal of the project was that the students would be able to use the knowledge of designing and building testing circuits to be able to measure a physiological signal or obtain a physiological signal. So what we did with the project, since the students were not able to build those hardware, was to use a combination of different software. So we started off with iWorks. So iWorks is a licensed software, and what iWorks is really very similar to BioPack and AD instruments. And what these instruments are, they're life science data acquisition and analysis systems that allow you to be able to record biosignals and also process them. So with iWorks in particular, I believe there are about 200 labs modules that are already created with experiments, and they support in hardwares for this particular experiment. So there's animal muscle, nerves, there's EKG, EMG, there are heart sounds, a combination of different experiments that are built in. And with this, what the advantage with this iWorks is that it comes with the components needed. It comes with the hardware and the experiments as well. So students can actually take the kits and then take them home and then bring them back. So that's an advantage of having iWorks in your labs. So that was one way that students were able to measure the particular physiological signal. Now, in terms of the building of the circuit and designing that, LT-Spice was used. So with LT-Spice, you can have your students design the circuits and also simulate their circuit. So they can run it, and then you can actually observe your waveform. And students were able to do this in LT-Spice. We also had them use Tinkercad. And with Tinkercad, the students were able to incorporate Arduino Uno to simulate the collection of this physiological signal. So with that, you can see there's an example here that shows the recording of the simulation that was generated on Tinkercad. So here's an example of and this is the code, and students were able to actually show a positive waveform to signal an extension, or a negative to signal a flex of a particular muscle activation. So for this particular group, they were looking at how to control or determine the muscle movement of a robotic arm, was what they were looking at. So the simulation here are the waveforms are generated. So students were able to use AutoCAD type software and LT-Spice software and existing or in-house physiological data acquisition system. So overall, we did incorporate the use of free software and also the in-house data acquisition system in order to provide lab instructions online. So thank you very much for listening.